Welcome, Alvin ISD students. Today's video lesson is over solving problems using qualitative and quantitative predictions and comparisons within probability. The standard is 7.6H. To get us started, we're going to do a brain warm-up. Go ahead and pause the video and try to solve this problem. Hopefully you have paused the video and attempted this problem by yourself. Now let's look at some ways that this could be solved. One way you could solve this is to look at the fractions. We know there are 24 cards and 1/6 of them are red. So what I would do here is I would look that there are 24 cards. I would divide them into 6 groups, and I only need one of the 6 groups. In that one group, there are 4. So now I'm going to do green. For green, I need 8 groups. So I circled 8 groups. And what I noticed, there are 3 in each group. Well, I need 3 of the 8 groups. Well, 3 times 3 is 9. When I look at blue, I need 1/12. So the 24 into 12 groups, there are 2 in each group. I only need one group of 12, so there are 2 blues. And for yellow, just like green, I need 8 groups. In each group there was 3. I need 3 groups of 3, so that's 9 yellow. Now that's one way to look at it. That could be used by multiplying fractions or just simply drawing a picture. Another way is to think about it proportionally. If I know there are 24 blank cards, I should be able to write a proportion which each of these values, ratios, rates, and be able to determine how many cards there are. So let's think about red. Red is 1/6. Well, it's 1/6 is how many 24? Well, I say 6 times 4 is 24, and 1 times 4, and so I get there are 4 red. I'm going to do the same thing now with green. 3/8 is equal to how many 24ths? Well, I did 8 times 3 to get 24, and 3 times 3 is 9. So when I look at my blue is 1/12. or 2/24, because I multiplied 12 by 2 and 1 by 2. Then finally, my yellow, which is the same as my green, is going to be 9. So here I looked at a ratio, a proportion, equivalent fractions. All of these things are very similar here. So this should get us started and get our brain thinking proportionally, because as we move on today, we're going to really need those and use some of that predictions that we've already taken care of. So in today's lesson, I will learn to describe outcomes for simple experiments as being more likely, less likely, or equally likely, which is a qualitative statement. To use qualifiers such as twice as likely and half as likely when describing outcomes for simple experiments, which is a quantitative statement, and solve problems using qualitative and quantitative predictions and comparisons. So for our learning targets, by the end of this lesson, I should be able to solve these 2 problems. If you notice, these 2 problems are from the standard 7.6H, and while they look similar, they also have a lot of differences. And by the end of this lesson, we can solve these. So now let's talk about some vocabulary. On the left here, we have qualitative. Qualitative is like, think of quality. It's a description. It's observed, but not necessarily measured. Then we have quantitative. And in quantitative, we have that word quantity. It uses numbers and can be measured. So when you're thinking about qualitative and quantitative, think about the words quality and quantity. So right here we have examples of some qualitative statements and some quantitative ones. Now these 2 are talking about very similar things, but it's looked at it in a different way. So let's start, if it's absolutely impossible, that's a 0%. So impossible means it can't happen, but to actually put a number to it quantitatively, it's not going to happen. Then we can go to the far other extreme. We are 100% or we are certain it is going to happen. Then somewhere in the middle, you have it's an even chance, like a 50-50. You have unlikely, which is a 25%, and likely, which is around 75%. So on the top, we have our qualitative, which have to do with a quality, and our bottom is our quantitative, which have to do with a quantity, a number. So what we're going to do now is we are going to read some statements. After I read that statement, I need you to pause the video and you need to decide, is that statement qualitative or quantitative? So let's get started. There are 75% more tickets for the school musical left to sell than there were last night. Pause the video and decide, is this qualitative or quantitative? Hopefully you pause the video and let's see if you are right. This is a quantitative statement because it says 75%. We're given a quantity. All right, let's try our next one. The fruit was placed in baskets for the meeting. If randomly selecting a piece of fruit, a person is more likely to select an apple than a banana. Pause the video. All right, let's see how you did. This statement is a qualitative statement, more likely. It didn't give us a number, it just kind of told us it would be more likely. All right, let's try our next one. The school cafeteria has 1/5 more days during the school year when pizza is served as days when hamburgers are served. Pause the video now. All right, how'd you do? This is a quantitative statement, 1/5 more. All right, our next problem. The average height of a 7th grade student is 15% taller than the average height of a 6th grade student. Pause and decide. All right, did you get it? This is a quantitative statement because we're talking about a quantity, 15% taller. All right, at Madison Middle School, 7th grade students are equally likely to select band as an elective as they are to select art. Pause and choose. Drum roll. The answer is, this is a qualitative. It says equally likely. It doesn't give us an actual quantity, just that it's a qualitative statement. So now we're going to take what we just did, it's talking about qualitative and quantitative, what we've learned from probability of finding simple and compound events, about making predictions, and put all of it together. We are going to apply all the knowledge from this unit. So we want to make sure that we are using the Alvin ISD problem-solving process. And that problem-solving process involves analyzing your question, planning and solving how you're going to complete the problem, and then justify and evaluate for reasonableness. So the very first thing we're going to do is we are going to analyze the problem. So in the blue right here is my problem. A 12-sided number die is rolled exactly once. Which statement is correct? So the first thing I notice is it talks about a 12-sided number die. Now, I do have a picture of one, but I probably want a little bit more information. So when I circled this or underlined this, I also want to tell myself, okay, let me see 1 through 12. These are called annotations. Annotations is making your thinking visible. So you're leaving your thinking behind so that you can easily continue on. Something else that's pretty important in here is that it's rolled exactly once, and that I am looking for a correct statement. So I have analyzed the problem. Now I need a plan to solve this. So the plan I'm going to use is I'm going to go through each answer choice and analyze those using annotations as well. So let's start with answer choice A. The probability of rolling a multiple of 2. Well, I'm going to stop there and I'm going to annotate multiples of 2. 2, 4, 6, 8, 10, 12. There are 6 of them on a 12-sided number die. Is 3 times more likely? Ooh, I'm going to annotate that. That's pretty important. Then the probability of rolling a multiple of 4. Well, I need to know what's my multiples of 4. 4, 8, 12. There are 3 multiples of 4. Now that I have made my thinking visual, I can easily go back and see, is this a true statement or not? So it's saying rolling a multiple of 2, there are 6 of those, is 3 times more likely than rolling a multiple of 4. There are 3 of those. Well, it's not 3 times more likely because 3 times 3 is 9. So this is actually an incorrect statement. But it is wrong because it's not 3 times more likely, it's only 2. So I'm going to say, nope, 3 times is what makes this wrong. Notice, I marked out what makes the problem wrong, not the letter A. A is just a letter. What makes the problem wrong? Let's go to B now. For B, the probability of rolling a multiple of 2, well, I did those earlier, but I'm still going to annotate it. 2, 4, 6, 8, 10, 12, and there are 6 of them, is 2 times more likely. Okay, I'm going to annotate that because that's telling me my quantitative comparison of rolling a multiple of 4. So again, I have a multiple of 4. The probability is 2 times more likely. Well, when I looked at A, I said, yeah, it's 2 times, not 3 times. So I really like this answer choice, but I'm not going to pick it yet, just in case I made a mistake. I'm going to call it my maybe baby, and I'm going to leave it there and come back to it. Because the only way I can know and justify that my answer truly is right is if I know the other ones are not. So let's check out C. The probability of rolling an even number, so let me annotate the even numbers. The even numbers are 2, 4, 6, 8, 10, 12, and so there are 6 even numbers, is less likely than the probability of rolling a 2-digit number. Well, the 2-digit numbers on a 12-sided die are 10, 11, 12. So there are 3 of them. So an even number, well, there's 6 of them, is less likely than a 2-digit number. There's 3 of them. It's not less likely, it's more likely. So this one is also an incorrect statement. So D, the probability of rolling an odd number, well, my odd numbers are 1, 3, 5, 7, 9, 11, which there are 6 of them, is equally likely as the probability of rolling a multiple of 3. Well, my multiple of 3 are 3, 6, 9, 12. So there are 4 of them. Now, there are 6 odd numbers and 4 multiples of 3. Those two are not equal. If anything, there are more odds than there are multiples of 3. So again, an incorrect statement. So my correct one was B. Now, when I think about the problem-solving process, I have to justify and evaluate my reasonableness. I can say that I truly believe B is correct because I went through each of the other ones and found that they were incorrect. Notice I used my annotations for each of these. Now, let's talk about our learning target, because really, this was an application of all the things we already know. This is one of the problems from our learning target. What I would like for you to do is pause the video and try to, I know that you don't have the problem, but annotate some of the important things on your piece of paper, or you could take a quick snapshot of this and annotate directly on your computer screen. After you pause it, we'll come back together and we'll go over it. So pause the video now. All right, I hope you truly paused it because here we go. The first thing in our problem-solving process is to analyze. So we're going to start by analyzing this problem. Leticia has 2 bouquets of flower. Each bouquet contains 13 daisies. Bouquet S contains 30 flowers. Bouquet T contains 13 flowers. Which statement is true? Here's what I did to analyze this problem. I knew 2 bouquets. Each had 13 daisies. So when I broke up my bouquet S and bouquet T, I put right here that it's 13 of 30 daisies. I'm using the information from the problem stem with the information in the bulleted list. Same thing here, 13 out of 13 daisies, because there are 13 flowers and 13 of them are daisies because it tells me in my problem stem. Then for my statement, it's telling me I am looking for something that is true. So now that I've analyzed my problem, I'm actually going to analyze each answer choice as part of my plan to solve this. So I'm going to start with answer choice A. Now, you've already read this, hopefully, because you solved it. So the probability of randomly selecting daisy from bouquet S is less than the probability of randomly selecting a daisy from bouquet T. So I need to annotate this. When I tell you I annotate this, if I was doing it with paper and pencil, I would legit put 13 out of 30. Where it says less than, I would put a less than sign. And then where it had the bouquet T, I have 13 over 13. Basically, I substituted what was in my information in my problem stem. So is 13 out of 30 less than 13 out of 13? Yes, because 13 out of 13 is a whole. So I like this statement right now. Okay, this is going to be my maybe baby because maybe I read something wrong. I need to keep going. Let's look at B. The probability of randomly selecting a daisy from bouquet S is 1. Well, let's annotate. Bouquet S has 13 out of 30 are daisies. That is not a whole. 30 out of 30 would be 1. So what makes this wrong is that either I'm looking at the wrong bouquet or it's not 1. So I'm going to go ahead and put the X on 1 because it's not 1. C. The probability of randomly selecting a daisy from bouquet S is equal to the probability of randomly selecting the daisy from bouquet T. So now I have to compare. Bouquet S, is it equal to bouquet T? So I put in there with my annotations, and no, they are not equal. So the word equal is what's wrong in that statement. Then D, the probability of randomly selecting a daisy from bouquet S is 1/3. Well, let's check out bouquet S. Bouquet S is 13 out of 30. Now, 13 out of 30 does not simplify to 1/3. To get from 30 to 3, I divide it by 10. If I do 13 divided by 10, I would get 1 3/10. So this is not correct. It is not 1/3. So that means if B, C, and D are incorrect or false, then A is my true statement. Notice, for these, I've taken all I know from my probability and I'm actually analyzing these using my qualitative and quantitative statements. I am comparing them and making good decisions using my annotations in my problem-solving process. Let's try the next one. For this one, go ahead and pause. All right, here we go. On this one, I'm going to go ahead and just show my annotations. So what I did for my annotations for the analyzation is I took my information in the top and I put it where it goes next to the bulleted list. I noticed that in my problem stem, it's asking for the best prediction. And when I see a prediction, I need a proportion. And my prediction is of 200 students. So in A, it says 16 are beef. So my annotation, well, beef is 12 out of 25. So I'm going to set up my proportion. 12 out of 25 is blank over 200. Well, to get from 25 to 200, I do times 8. So 12 times 8 is 96. 96 and 16 are not equal. So that is incorrect. All right, let's look at answer choice B. For B, we have the chicken or pasta. So we're going to add those together and get 13 out of 25. So 13 out of 25 is equal to what over 200? Well, 8 times 25 is 200, and 13 times 8 is 104. 104 is not 52, so this is incorrect. On C, it's saying that it's 32 more. So when I look at beef and chicken, I need to see how much more beef is than chicken. So 12 minus 8 is 4. That's how I get my proportion. A 4 over 25 is equal to what over 100? 4 over 25 is equal to 32 over 200. This looks like a correct statement. I want to call it my maybe baby though, just in case I made a mistake. So let's check out D. For D, it's saying 24 more for pasta than chicken. Hold up. Pasta and chicken, pasta is less than chicken. So this statement is incorrect without having to do any work because it is not more. So the correct answer is C. Again, I use my annotations to lead me to this. So just to recap, today I learned how to describe simple experiments using a qualitative statement, a quantitative statement, and then solve problems using qualitative and quantitative predictions and comparisons. Check, done for the day. Thank you for joining us for this lesson.